I really want to thank everybody for coming out this morning. If you're not, usually a Verona Historical Society member, but I have to say that listening to all of the people who were able to share their thoughts and memories about the old schoolhouse was just wonderful for me, because all of my kids went through there, all 6 years of grade school. So we've got 24 years in that schoolhouse between all of them. It's amazing. So it's really been very special. I want to tell you about the work that we're doing, and I know that everybody comes in knowing different things about my field, anthropology, and the stuff that we know about human origins. I can tell you a small sliver of it, really. We've got some really exciting discoveries that we've been making in South Africa, and they're, it's been just an amazing experience for me. And one of the things that I'm really privileged in is that we have had National Geographic involved with our work from the start, and also UW has been involved with the work from the start. And both of those sources have given us lots and lots of video and recording of the entire process. So this is really one of the first discoveries that we've ever made anywhere in the world, that the moment of discovery is on film, and people's perspectives on it ever since then, and all the work that's been done. And so I always like to start by showing this little film of one of the discoverers, and you'll see both of the guys in there who discovered these fossils, Stephen Tucker and Rick Hunter. And you get to hear in people's own words sort of what was going through their minds.
Caving has always been great. Caving, you want to answer that question of what's around the next corner. That's like always the question you want to know. It's mostly fueled by curiosity. But as you get into caving more and more, the scientific side of it comes into it. You want to know, how did these places form? What happened here millions of years ago? What happened here billions of years ago? Basically, it creates a fascination with this whole environment. In my wildest dreams, I would never have thought that caving would take me to what's happening here. You can almost call this a bit of an accident. So my caving buddy and me, Rick, we were out exploring this cave on a Friday night. We'd gone into a very remote section of the cave, part that I'd never been in before, and in that section, well, we stumbled upon fossils. Yeah, at first we didn't exactly know what fossils yet. We started looking around a bit more until we found a mandible, and that was when we knew this was probably hominid. That was when we got excited about it. And since this discovery, it's crazy what's happening here. Pedro Boshoff is a geologist. He's been caving in this country for 30 plus years, and he was asked by Lee to basically go and look for fossils in deeper areas of caves. And he'd then spoken to myself and Rick and a few others and said, oh, he needs us to come start looking for hominids. And on this whole expedition, he has been in charge of the cavers, coordinating who is here and what we have to do and getting everything organized for us. Since the start of this expedition, from the cavers side, we've been putting in over 2 kilometers of cabling. Those are for cameras, lights, communications within the cave. We've also put up safety ropes straight throughout the cave for the safety of the scientists, making sure there's no injuries, and we're here for backup, that in case something does go wrong, we are here to assist as soon as possible.
So the video that you saw with them going into that chamber, you see bones on the floor of the chamber, is the video of them on their helmet cams encountering those fossils for the first time. I'll tell you a bit about the way that we look for fossils. You guys know that fossils of humans, human relatives, our ancestors, are incredibly rare. They're some of the most precious objects, in scientific terms, that exist in the world, because there's so few of them. There were millions upon millions upon millions of people over the millions of years that our ancestors lived in Africa and in other parts of the world eventually. And of those, we've recovered little bits and pieces of a few thousand. And what I'm going to show you from this site is right now some of the most voluminous evidence of human origins, human evolution anywhere. So it's an amazing discovery. Many of you know the story of the Leakeys and their discoveries in East Africa. And those of you who sort of follow some anthropology, archaeology, maybe are familiar with views across really desert-looking badlands that have big hillsides of eroding stuff and fossils coming out of them. That's one kind of context in which we find human fossils, human origins. But in South Africa, it's a very different context. In South Africa, we have caves. And those caves have existed underground, in many cases, for billions of years. But they become exposed to the surface and become caves that animals and other creatures and human relatives accessed and went into. And sometimes the remains of those animals and ancient people ended up in the caves, either because they were using the caves or because they were the prey of lions and leopards who were using the caves or bringing prey back to the shade that the trees make around the caves. And so we find bones in the caves where groundwater, as it's percolating down, sometimes cements them together into fossils. And so we have, outside of Johannesburg, South Africa, a very large expanse, about a third or a fourth the size of Dane County, that has these caves where we've found fossil evidence of ancient humans and human relatives. Until about 10 years ago, there were 3 major sites where those had been found, and 3 or 4 other sites where you'd found a tooth or two. And that was amazing, right? This is some of the greatest evidence of human origins. My friend Lee Berger, who is presently an explorer with the National Geographic Society and a professor at the University of Witwatersrand in Johannesburg, in 2008 discovered a series of fossils from another cave that was previously unknown. That cave was called Malapa, and the fossils he discovered were Australopithecus sediba, a new species. And so that was really newsworthy, and he spent some time working on it. I began working with him during this period and traveling to South Africa. The thing that Lee did that most other people working before hadn't done is to assume he hadn't already found the most important thing he was ever going to find. And he kept looking for more things, right? And one of the aspects of it was he talked to these guys, Pedro and Steve and Rick, who you saw, and said, you know, there are going to be other discoveries, and the place where you need to look for these is in parts of caves that people haven't been going into. The Rising Star Cave has about 2 kilometers of underground passageways, and was well known to these caving guys. They've been using it for more than 50 years for their caving expeditions. 2 kilometers sounds like a long ways, but it's actually very compact compared to some of the caves they get excited about. They get excited about the one that they love right now is a cave called Armageddon. And it is probably the largest cave in the southern hemisphere, and it's unexplored, and they go camp underground and explore parts of it and squeeze through things. Well, the Rising Star Cave has these areas that you squeeze through. You saw them doing it. I'm going to show you a couple of short videos of some of our team squeezing into places, and you're going to see this is crazy. How many of you guys have been to Cave of the Mounds here? Almost everybody, right? There is no part of Cave of the Mounds, correct me if I'm wrong, it's a pretty small cave. There's no part that you actually have to squeeze your body and you have rock on the front and back of you, you know? How many of you have been in a cave where you have to really squeeze like that, where it's like, yeah, and crawling, you know, sort of slithering around? Anybody do that, like crawling through? Yeah, so you've got a picture of this, right? Well, this passage that we're talking about in the Rising Star Cave, this is our laser scan data. We've got laser scan data throughout the cave. We've put machinery down in there to give us really accurate point cloud data of the walls of the cave leading to where this group of fossils are, the Dinaledi Chamber. This is the entrance that we use up at the upper right. As you can see, there are parts of this cave that are super narrow. The Superman's Crawl is called that because in order to get through it, it's about 10.5 inches high. And in order to get through it, you have to have one arm forward and one arm back, like Superman. Right? So it's pretty rough. The chute that we climbed down, I'm going to show you some video of this in just a second. This is a 7.5 inch passage. It's a wide crack that's 7.5 inches, and you're going to see people doing this. It's 12 meters, so about 40 feet of a climb down. It's vertical. And so when you saw Stephen there wedging himself down into that crack, when he did that the first time, he just felt that there wasn't a bottom, and he said, "What's down there? I'm going to go find out." Because it wasn't on the map. They didn't know what this was. This was new to them. And in fact, as far as we know, only one person had ever been in it before that, and they hadn't left a record of it. They left a survey marker, and so we know that someone was there. But they didn't recognize, as you guys saw, what was in the chamber.
Did he go head first or feet first?
Feet first, feet first, feet first, yeah. So we were faced with a special problem. How do we find people who can actually get into this chamber with the bones and work there, right? And Lee, knowing this discovery, and the caving community, these guys talk to each other, right? And they've been amazing, right? They work with us. They're committed to working with us because we conserve the sites, because we're not dynamiting. You know, in the past, archaeologists have dynamited sites to get the fossils. And so we have tremendous, cooperation with the caving community, but this was on private property and not guarded or fenced in any way, and word of discoveries like this get out, so we had to actually move fairly quickly. And so Lee put on Facebook an announcement. We have a discovery and we need people who can work on it. The catch is this: you have to be skinny and preferably small. You can't be claustrophobic. You have to be available to come to South Africa next month. 60 people replied to this, and from that, Lee was able to select a team of 6 people. Here you see them. Leah Gertoff, second from the left, was a University of Wisconsin student at the time. And Marina Elliott, who's here in the center, you're going to see her a couple more times because she's now administering all the underground exploration for our team. So tremendous team of committed people. And we, in 2013, had an expedition of more than 60 people on site working underground to keep those 6 people underground for 20 days. All right, let me show you this video. This is Becca Peixoto. She's one of our team members, and she's climbing the chute. That's that very narrow passage. You're going to see her do something amazing here because she's going to squeeze back into this little pocket that none of the rest of them knew was there. When Marina saw the video for the first time, she said, "Where are you?"
Okay.
Becca is about 4'9" and very little, and she's just on a camera switch, and you're going to see Marina climbing.
You're protected. I'm not going anywhere.
Up the next stage of this. I mean, they are just, I don't fit, right? I don't know if you've gotten that impression. This is a very, very athletic, special kind of endeavor, and it's amazing that we were able to find on such short notice such skilled people who had the underground equipment, the underground skills, and also the archaeological skills. But what's even more amazing is that they've all remained engaged with our project, and so we've had them out several times to work on different aspects of this. You're going to see the results of a lot of that. You might wonder, what do I do? And I wonder that myself sometimes, I'll be honest. This is Ellen Feuerriegel, our Australian team member, who's coming up the last phase of this. There's nothing like being able to show what this is like to get into these places. Sometimes people ask, why don't we change the cave? And seeing it answers that question, right? Because the bones are underneath this passage. If you did anything to alter that, you went in there with a jackhammer, you're damaging the site where the bones are, and we're talking about 40 feet of it, right? This is a real case in which the human skills are absolutely necessary. Over 20 days, we recovered more than 1,200 fossil remains of that puzzled us, I'll be honest, right? What do? I figure out what this is what I do. And when all these bones came out, I was very puzzled. We went into this chamber expecting, you guys saw the video. We had the same video as you. I knew what I was gonna find. I was gonna find the bones of a skeleton, and probably lots of bones of other kinds of animals that would also have been there in the cave. And from the video, you could see that there, were some clearly human-like bones. We could see enough from the photos that we had to know that this was not a modern human. This wasn't a crime scene that we were finding. This was some sort of ancient creature that is a relative of ours but isn't a human. And we had some ideas of what it might be. There have been other cave discoveries within 2 miles of this place that belong to species that are really well known to science, like Australopithecus africanus as an example. I'll show you some of these skeletons. Australopithecus africanus, this skeleton came from about 1.5 miles from the site where we're working. And we thought, well, looking at the pictures, we might have a skeleton of this or of another species that we know of that lives there, Australopithecus robustus. We're gonna find a Lucy. We're gonna find something like this. Here's Lucy's skeleton. You guys have heard of Lucy. Ethiopia, about 3.5 million years old. And here's the kind of thing that would really make our day, is if we found a skeleton that was better than this one that we already have of one of these other species. It would be one of the most important discoveries ever made. When we talk about skeletons of fossils, they're incredibly rare for human relatives. Right? I've got lots and lots of bones and lots of teeth, but you find one piece of a thigh bone of somebody, you find part of one of their jaws, and we put together evidence based on those pieces. But to have something like a Lucy or like a Turkana skeleton, this is a Homo erectus skeleton from about 1.5 million years ago, to have something like that puts all the pieces together, right? It's like having the entire guide to the ancient creature. And that's essential for us in science, and the cases of that are here. These 2 fossils, these 2 skeletons of Australopithecus sediba, are the ones that Lee's team found in 2008. They added substantially to our knowledge of fossil hominids. And we were going to find another, and that was going to be amazing. What we found, as we quickly discovered, as bones were coming out of the cave, was the remains of at least 15 individuals. When I show you, these are the bones that we recovered, right? They're now on display in South Africa. Anybody who's in Johannesburg can go and visit these. It's amazing. We found the bones of at least 15 individuals, of all ages, babies to very old individuals in this population. But the thing was that we were puzzled because different parts of these bones looked like different things. They didn't belong to something we already knew about. There were a few parts that looked like another species we might have known about, but other parts looked like other species. It looked like a combination that we had never seen before. To understand this, we recruited again from Facebook, actually, and from our professional networks, a team of more than 30 young early career scientists to come to South Africa and to spend time together studying and interpreting these remains. They compared them systematically to every other discovery that our field had ever made. And what they found was that we were dealing with a creature that we had never seen before. When that happens, we try to figure out what to call it, and so we named this species Homo naledi. Naledi means star in the local language that's spoken around the site, Sesotho. So we have star person, star people, after the Rising Star Cave where we've done our work. Homo naledi is really interesting to us from a scientific point of view because it's, first of all, better documented than any other species that we've had from this time period or earlier. And second of all, because it expresses a combination of traits that we thought were impossible. I'll give you a couple of examples. Its skull has a very small brain. This is one of the more complete skulls at the site. We've mirrored it here. to show it inside of a human brain. You can see that in volume it's about a third the size. So this creature had a brain about the size of an orange, about a third the size of a human brain. So very primitive looking in that sense. You can see it's got a brow ridge that protrudes in front of its skull, etc. These are traits that we've seen before, and we see them in very primitive species that are the earliest members of our genus, Homo. Homo habilis, for example, discovered by the Leakeys. It's a creature that's similar to this in its skull, but this is an even smaller brain than Homo habilis had. So it's very primitive. My friend John Gurche, who's a paleo artist, an artist who specializes in reconstructing the appearance of fossils as they were in life by studying the anatomy of humans and our relatives, the great apes, has put together this reconstruction of what Homo naledi may have looked like. And I think that's as good as can be done at the moment. Obviously, some aspects, like the pattern of the hair, are speculative, but they're documented by their relationship to other kinds of apes and humans. So it's as good as anyone can do. This is one of my favorite slides because this, more than anything else, shows you the composition of the population that we're looking at. These are teeth, and they're teeth of the upper and lower jaws of 6 different individuals. We know the teeth that go together because teeth in your mouth and my mouth and everybody's mouth wear against each other, and they develop these little facets on them from wearing against each other. Most of you, even in the golden generation out there, have the occlusal parts of the teeth, the parts that grind against each other, are not really very worn. You know, you have a little bit of polish on them, but we don't wear our teeth like people did when they were grinding grain on grindstones, or when they were eating wild food, as these creatures were, well before agriculture. Their teeth wear down, and you see that wear here. In the oldest individual here, the teeth are worn flat and there are parts of them where the dentin is becoming exposed. That's not a cavity, this is natural wear. In fact, there's no caries or any kinds of signs of any pathology on any of these teeth. They're super healthy. And that's the case of most prehistoric people, well before agriculture. Most of these dental problems that we have came in with grain and with sugar, the agricultural foods. So these guys didn't have it. But what we can do is look at the wear in between each of the teeth. That tells us which teeth were adjacent to each other in their mouths, and you guys have that. If you try to floss and you find that you've got teeth that are hard to get between, those teeth have actually worn flat against each other. And when people say, well, you've had your 3rd molars removed, how many of you have had your wisdom teeth out? Right? The reason why orthodontists do this is because when those come in, if they're going to come in, they exert pressure on the rest of the teeth, forcing them forwards. And if you're not eating a very chewy, hard diet, like a natural foods diet, the front teeth aren't pushing back. And so your front teeth will get misaligned. And so there's not usually a big health reason for some. In some people there is, right? The molars become impacted. But for a lot of people, there's not a big health reason to take them out. It's an appearance reason. They want your teeth to be straight. These guys chewed hard stuff with the front of their mouths and their teeth remain straight, but that creates a pressure that creates wear in between these teeth. And so we can actually tell which teeth go together, even if they're scattered in the site, which is what we've got. You can see that wear happening right here. That surface is just a worn surface between this premolar and this first molar, and this 2nd molar is unworn at all. It's just coming in. This is about a 10-year-old individual if it was a human, in human age. We don't know that they were. We think they probably grew a little faster. We've got scans. These are recent. This is a paper that our team published last year. Here's one of the younger individuals, about a 2-year-old, and you can see this first molar coming in, and we're studying the development of these compared to each other. Here's a 2nd molar that has not yet come in, but this canine is already in. That's a human-like pattern of development. That's something that doesn't happen in great apes. So a mix of characteristics when you look at the teeth, and those teeth are about the size of yours, I'll tell you. They're not big teeth. They're about human-sized teeth. The foot is a human foot. absolutely human foot. My student, Zach Throckmorton, he finished his PhD with me. He's now an anatomy professor in northeastern Arkansas, and he's studied the feet, the foot bones from the site. His dad was a podiatrist. And he didn't want to do his dissertation on feet. He didn't want to be feet at all. He wanted to do genetics. And he was having a miserable time at it. And he did this little side project one day on foot bones. And he was so excited and animated, and anyone talked about it, he'd talk about it all the time. And I pulled him aside and I said, Zach, what are you doing with your life? You know more about foot bones than any but 5 people in the world. And here you're doing this thing that you're really bad at. You need to change. He did change. He studied our feet. And I love this story because when he came to South Africa, he's in this lab full of people, all of them with, it was like kids in a candy store with these bones that had never been studied before. They're going to figure out what they are. And he's looking at these teeth, and you just see his shoulders slump. And he's looking at these teeth, and he's like, or he's looking at these foot bones, and he's like, I walk over to him and I said, what's going on? He says, why did you bring me here? And I said, well, isn't this exciting? Nobody's ever studied these before. It's the first time ever. He said, these bones are completely unremarkable. I said, what are you talking about? They're amazing. He said, these bones are identical to human foot bones. There's nothing special about these at all. So I actually got him up out of his chair and I pulled him across the room to where people were working on the skull, right? And you guys saw the skull. I said, is there anything remarkable about that? He said, yeah, that looks like the skull of Homo habilis. That's amazing. And I said, well, these are in the same body. There's something really puzzling about that. And that, in fact, was the story. You can see the arch of this foot, and here's these bones. This is a cross-section through the foot right here, so you're looking at the ends of these metatarsal bones. So you can see the arch side to side of the foot there. It's a human foot. It's size 4.5 if you're a female. Women's size 4. Hands are amazing here, and the hands have this mixture of characteristics. This is a complete hand. We found it in the site just this way, right, with the fingers curled over, right? So one of the big signatures that we have here is that they entered this site as bodies because the soft tissue must have still been connecting this hand and some other parts when they entered this site. We do not have bodies laid out like graves, you know. This isn't like this isn't like the former poor farm. We're not going to put stones there. It's not happening because the bones are very jumbled. But we have parts of them that clearly were fleshed, that had the soft tissue remaining when they entered the site, and this is one of them. Just to go back to this. But those hands, you see the thumb is a human-like proportion. It's a long thumb. Chimps have very short thumbs. The fingers are human-like in proportion. They have wide fingertips, and we relate that to gripping things and holding powerfully. This is necessary for tool making in humans. That's why we have these broad fingertips. Apes and other kinds of primates don't. They have very narrow fingertips. The wrist is configured like a human wrist. And that's more human-like than Homo habilis, for instance. It's a derived character. But this bone, this first metacarpal, the bone that roots your thumb in the palm, we've never seen anything like it. It's got this narrow little base and this wide end, and it's got these big ridges on it. If I showed you a human bone like this, it looks like a cartoon bone that a dog would have in a cartoon, right? Like, I don't know, Pluto, Mickey Mouse's dog. If he had a bone, it would look like that. 2 little ends in a very narrow middle. It wouldn't look like this. This looks like a chicken leg. It's fat on the end. We don't know why this is. We know their thumbs were powerful, more powerful than we'd ever seen in any other creature, relative to their small hands. They're not my size. They're maybe one of the smaller women in the room would have hands about this size. So if we look at what their body would look like, and I'll just summarize the parts. They're skinny. They have shoulders that are sort of canted upwards like this. They have very powerful hands. They're about 4.5 to 5 feet tall. So they stand about like this. About like this. This is Lucy as a reconstruction, so an earlier hominid, 3.5 million years old. This is Turkana-Boy, 1.5 million years old. Our thoughts had been that there's a transition between these. And this sort of looks like, well, maybe this is part of the transition, right? Maybe this is something in between. Evolution happens, and we might be finding something right in the middle. So let me take you to some of our more recent discoveries about this. One big mystery that we had when we first did this analysis, when we first published these results, was we didn't know how old the fossils were. Another big problem that we had was we didn't know how they got into the cave. As I told you, what we expected to find. We expected to find some bones, the bones of other kinds of animals jumbled together. We expected that they would have been coming out of some sort of more fossilized deposit. We don't find bones on the floor of a cave in soft sediment like that. But these were all there. And there were no bones of any other animals. It was all Homo naledi. We don't see contexts like that anywhere. That was weird. And certainly in this part of the cave, deep down in that very narrow shaft, that's very strange. This is the Dinaledi chamber, and this is the pathway that we take through the cave to it from the entrance. At the same time we were working in the Dinaledi chamber, our cavers, Rick and Steve, were noodling through the rest of the cave, and they found a second place, the Lesedi chamber, a second place with bones. We began to investigate those bones in 2014. As we did, we realized that we had more bones that looked like Homo naledi in a second part of the cave. The route to the second chamber is not quite as hard as the one we do because there's not quite as long a vertical narrow drop, but there are parts of it that are very difficult to squeeze through. One of them is called the Burger's Box today because Lee, my friend, has been to this site once. And when he came back, he got stuck. It was like Winnie the Pooh. It was crazy. There's this narrow place, and he could get through it one direction because you're using muscle groups to go down and using different muscle groups to go up. He was stuck, couldn't make it out. He was there for 45 minutes. It was you know, he's a diver, and so he's used to that sort of maintaining mental discipline. But I was looking at it, but the mental discipline I had was that, well, if you squeeze through that direction going through, I'm not going to make it because I'm a little bigger than Lee, and I'm like, I'll see you later. And it was like 3 hours later, right? And I'm like, they're finding new fossils, and here I am. And when he was stuck, that was payback. No, it wasn't payback. It was very scary, actually. But we have, from this part of the Lesedi, we have now at least 3 individuals, probably more, honestly, of fossils from here. But in this part of the chamber is the Neo skeleton. This is the skeleton of an individual. This is our Lucy. And you can see the wonderful thing about Neo. We've got large parts of the vertebral column, we've got arm and leg bones, shoulder. We've also got one of the most complete skulls ever discovered in the fossil record. Here's Neo's skull. It is really, really striking. This photo, I'm really proud of this, was chosen last year as one of the top 10 science images in the world. We published these fossils last year. The Neo skeleton is just an amazing discovery. An older individual, probably male based on its size compared to the others, but in its anatomy, it is just a twin of the bones from the other chamber. Here's Neo's jawbone and the most complete jawbone from the Dinaledi chamber. We have bones of this species in 2 places in this cave, far separated from each other. They're more than 100 meters apart to get from one to the other, in incredibly narrow passages. I'll tell you guys, we have bones of Naledi in other parts of this cave too. It's riddled with Naledi. A big question is, where does Naledi fit? And here are 3 of the skulls of Naledi. Here are some skulls of Homo erectus. Here are some skulls of archaic and modern humans. So these are very human-like. This is a early modern human, one of the first. So our species. And then you've got things like Homo habilis. You've got things like Australopithecus, or very primitive things, right? And Naledi, similar to these guys in a lot of features, and very small-brained like these guys, somewhat like Homo habilis or Homo erectus in its shape of its skull, but a smaller brain. We're looking at this and thinking, this goes way back, right? This is something that's just at the beginning of our kind of creature, just the beginning of Homo. And we had a debate about, do we put it into Homo, which is saying that it's a close relative of ours at the beginning of this human line, and closer to us than some of these more primitive things. Here's its brain size. Smaller than habilis, smaller than other Homo species, bigger a bit than Australopithecus. What remained unanswered and that we were able to address last year was how old the fossils are. The basic timeline of our evolution is we divided from chimpanzees about 7 million years ago. The earlier members of our line, our family, were called Australopithecus. And they had small brains and small bodies, and they walked upright like us, but were primitive in a lot of respects. They lived in Africa and nowhere else as long as we know, as far as we know, and they survived until 2 or 1.5 million years ago. Around 2.5 million years ago, some of those Australopithecus-like creatures began to make stone tools. They began to rely more on meat and other higher energy foods, and they increased in brain size. That gave rise to species like Homo habilis and Homo rudolfensis. Homo erectus was the first to have a very human-like body size and a very human-like skeleton. And after that, after 1.5 to 2 million years ago, humans evolved mainly by getting smaller teeth and bigger brains. And as a consequence, they became more and more like us until modern humans arose 200,000 years ago, again in Africa, from which they spread to the rest of the world. That's a thumbnail of what we thought 3 years ago. In our cave, it's very hard to figure out how old the fossils are because they're not fossilized inside of rock. They are slightly mineralized inside of a very soft sediment, and that doesn't give us a lot to work with to figure out how long ago they existed because we date rock, more or less. But there are flow stones that have formed in the cave. Those are made by dripping water inside of caves. You guys have seen them, stalagmites, stalactites, and sheets that we call flow stones. And this one actually embeds a piece of Homo naledi. Here's a picture of it closer up. So we've got this bone inside of a flowstone. So the flowstone formed on top of the fossils, so that gives us a minimum age. The fossils were there first, and the flowstone formed later. We have another means of determining the age of things from crystals. And the one crystal in your body that's most useful for this is your tooth enamel. The enamel in your tooth is a crystal. Crystals, when they form, trap electrons. And after a crystal forms, electrons can be disrupted from their lowest energy state by radiation. There is radiation in the ground that comes from uranium that's in groundwater. It's everywhere. And the amount of radiation in your local environment depends on what your uranium content is and radon content in your groundwater and your ground. But we can estimate that by going to the site and collecting sediments. So teeth of animals, after they're buried for a long time, will have a certain ratio of disrupted electrons compared to their lowest state electrons. And that's caused by the accumulation of radiation over time. We can use that accumulation to estimate how long they've been underground. And that's called electron spin resonance. And here's 3 of the teeth that we sent to Australia for our team to destroy. And you can see here some of the amazing things that you can measure the uranium content. These are teeth. And you can see here these tiny, 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 tiny holes that they've drilled with a laser on these to measure the uranium content of them. As a consequence, we came up with a complicated graph. I've got to get a simpler graph. I want to tell you that The flowstone, which is younger than the fossils, is about 236,000 years old at the most. And the teeth from the crystal disruption of the electrons are 335,000 years old at the most. And so that tells us that these fossils existed between 230 and 330,000 years ago. They're not millions of years old. They are fossils that existed alongside these early members of our species in Africa. Our species wasn't alone. Homo naledi was there with it. And we never saw it before. That's really striking, right? It tells us how little we know about this ancient time period, that there could be an entire species there in one of the best sampled parts of the world. We're 2 miles, there are 3 other fossil sites from us, right? This is somewhere that we've really looked for fossils a lot. And there's something fundamentally new. The idea that you could find something new where you've been looking for 100 years for things tells you a lot about the rest of the world, where there are large areas where we've never actually surveyed, we've never looked. So this is really striking. This is something that for us as anthropologists is really humbling, to know that there's more out there that we didn't find. This fossil also could be around the same. It's probably lived alongside of Naledi. This is from Zambia, right? So this is amazing. Where does Naledi fit in our family tree? We're not sure. It is primitive in some ways compared to species like Erectus, so maybe it should be deeper in our tree. But it has some traits that it shares with us, as you've seen. So maybe it should be closer to us in our tree. We're not positive. In fact, the evidence that we have from Naledi is better than evidence that we have from other species. Our limit on figuring out the tree is that we don't have parts of Erectus that we have of Naledi. We don't have an Erectus hand that we can compare to Naledi's hand. It doesn't exist. We haven't found one. We don't have an Erectus foot. So there are parts of Naledi that we know more about than anything other than humans and Neanderthals, right? These species that existed within the last 500,000 years. Well, Naledi did too. It was there within the last 500,000 years. This last September, we went back to the site. We conducted more excavations in both chambers at once. We had teams in the Lesedi chamber and in the Dinaledi chamber. I was in the command center. We were coordinating between both chambers. And we've got some amazing discoveries from this. I'm going to share just one of them. The Dinaledi chamber is complicated. Our team drops into the chamber here. We dug right here this September. We had previously dug way down here because this is where the fossils were sticking out of the dirt. And so that's where we dug. But a natural question is, if the fossils are way down here, but we come into the chamber up here, is there any fossils here? And so we dug here, and we have exposed now right here at the base of this chute a partial skeleton of Naledi right here that is now sitting there on the sediment at the base of the chute because we can't get it out. There it is. We'll figure out a way, but right now it's very hard. When you expose a skeleton, you don't want to disrupt the spatial relationship of the parts. We have part of a wrist and hand there, intact. We've got part of a rib cage, it looks like, intact. And so getting that out so that we can study how it was fossilized and how it was formed is going to take us actually bringing it out as a chunk. And that out of the 7.5-inch hole is not real easy. We'll get it, but it's not going to be easy. And the other thing that we discovered was back in these very narrow chambers. I think I've got a map of this. I'll show you this map. Yeah, we now have a much better map of this chamber. And behind where our fossils are, this is where we enter the chute. This is where we have now a partial skeleton. This is where we have the more than 1,500 remains of other, at least 15 individuals down here. There are all these tiny passages, right? I'm showing you this map, and you're thinking, wow, you know, this hallways that you walk down. No, these are like this. These are like this, right? These are cracks at best. And I'll show you, right? Here's Stephen going into one of them. You're about to see him take off his helmet because his head is able to fit, but his helmet is not.
That's all right. Don't do that.
The whole thing is like this. It just goes and goes. These are just very narrow cracks. The reason why I'm drawing your attention to them is because we've got bones in the bottom of them. The bones just keep going. Our best idea of how these fossils got into this cave is that Homo naledi put them there. They were deliberately brought into the cave. But they're brought into what are presently very remarkable situations. We're not sure how good Naledi had to be in the dark to do this. Right? We are still studying the more surface areas of the cave to understand how big it was at that time and how easy it would have been to get far back into this cave. If it were easy, we would have the bones of lots of other animals there, because other animals would also access these parts. So the fact that we only have Naledi tells us that it was hard, but we don't know how hard. We think the most logical barrier to other animals was that it was totally dark, and so they would have needed light. But we're not sure of that, and in order to test that, we obviously have to find some evidence that Naledi was capable of making light, that they were using fire in the cave, for example. We don't know whether Naledi was using more surface parts of the cave. Presently, they're filled with sediment that has come in from outside the cave. And we're going to have to dig into that to find whether Naledi left archaeology or other kinds of remains in the cave that would indicate their presence there. So that's a lot of work, because we're dealing with a room, this room full of sediment that we're going to have to do archaeology in. But we do have some stone tools in that. So we don't know whether they're connected to Naledi or not until we've dug in such a way that we can figure out the ages of them. So we have a lot of work to do. It's going to continue in this site. We have further discoveries that we've made. Our work has had a tremendous impact. This is the next president of South Africa, presently the deputy president, Cyril Ramaphosa, and very likely to be the next president when the next election comes along. And here he is with our fossil. We get to the New York Times. It's just amazing to be a part of a project like this. The fossils are on exhibition now for the public, and school kids are coming through every day. My wife the school kids were there when we were there last, right? Yeah. I mean, there's huge crowds of school kids. It's just amazing, and everybody. So that's what I want to share with you. I will say that our fossils are all online. Many of them are online. And I do have a bunch of these prints of the fossils. We've been doing a lot of school events, and have everybody around the world is able to download these models and print them on a 3D printer now. So we've got these out for everybody. If you've got a 3D printer, you can have Naledi in your house. You've got all the stuff that National Geographic does if you've got a printer, because it's sort of neat to work with Geographic, but it's also sort of neat to be like, well, we don't need you. We could do this ourselves. This is the copy of the skull that you see there with the deputy president. I'm happy to have you guys have contact with these, look at them. I've got a lot of these copies after the talk, but I'm also happy to take some questions if anybody has them. Yeah, let's go ahead.
You said that your friend got stuck.
Yeah.
And I'm just wondering how you get him out, or what is the process to get, unless there's, obviously you have communication with the surface.
If someone gets stuck in the cave, what's the process? Yeah, they have to lose weight.
Quickly for you.
We have a lot. In this case, it was actually a matter of having other people pull him in such a way that the narrow part of his body was hitting the narrow part of the rock. And that wasn't easy because it's a very confined space, and it was a real, if you're very body aware, you think about how your body is configured, that's what you have to do to be able to get into these little parts of caves. We have not yet had a serious injury in the course of our excavations, and that's been amazing because it is a hazardous, dangerous place, and our people are very highly trained. And those of us on the surface who are coordinating underground are also trained to deal with those situations. If someone were injured underground in such a way that they could not get themselves up, our protocol for that is to send down people to take care of them until they heal. So it really is a commitment to be in this situation. And our exploration team has now, it's the most trained, most skilled team in the Southern Hemisphere for sure for caving, and one of the most skilled in the world. They have regular, they're doing ropes. They're in the field 3 days a week, and the other 2 days they're doing training of all kinds. So they're very committed. And they work for us. It's now their profession. Yeah.
Well, how long can you stay in the cave underground?
Our team has found that they prefer to go in the morning and work for about 6 hours, and that's a long day, honestly. There are days that we really want people to come up sooner, but it takes at least a half an hour for our most skilled people to get into the position where they're working underground. So you're looking like it's a commute. And you don't want to do all that work and be down for 2 hours. You really want to. People will ask, do they have a bathroom? And the answer is there is a protocol for waste, and we deal with it underground. Yes.
I'm interested in the thumb bones that you showed
Yep.
with the wide end of them. That's where the strong muscles of the thumb attach.
Yeah.
Were like opposing thumbs.
Yep.
They had, I presume, opposable thumbs.
That's absolutely right. Yep.
Did you find tools that they've made anywhere that you think were used by Naledi?
We have, and I have to be really precise about this, right? Because you think of the evidence that we have to present about if we find the tools, right? What do we have to know that Naledi made the tools? We have to find them in some sort of secure underground, the context that we've dug that is connected, and we have to establish that they weren't possibly made by somebody else. We don't have tools with the bones of Naledi. We do have tools in the cave, and we're not yet able to establish whether they could be the same event, the same time, or whether they're different times. Tools could have come in later, they could have come in earlier, so we can't be sure.
Did they bury the bodies with any artifacts like necklaces?
Nothing whatsoever. It is just bodies. Yeah?
Are these fossils all mineralized, and know is there rock? They're not.
They are, to describe them, and it varies by piece, right? And within the site, there's different groundwater conditions, so some of them have experienced different conditions than others. Some of them have mineral deposition of calcite inside of the marrow cavities of the bones and slightly on the outside. Most of them are stained by the deposition of manganese and iron oxides on the outsides of them. But for the most part, the bones are the original mineral content of the bone that has been leached of most of its organic material. So the collagen that holds the bone together is mostly gone. You have the original bone material with some replacement with calcite, but they are not rock in that sense. They are not highly mineralized or silicified.
Can you check DNA of these things then?
We have had 3 different labs at this point sample the bones to attempt to get DNA. They are unable to get DNA that they think is endogenous to these bones. There's always environmental DNA, right? DNA from fungus and that sort of thing. The labs are the best in the world, and they've told us that with their current technology, they've done what they can do. We're continuing to monitor the technological changes. We think it's a better chance of DNA than almost anywhere else, of this age. But the circumstances for preservation of DNA, it's better if it's cold. And the cave that has the best ancient preservation of DNA, some of you have heard about this, Denisova Cave in Siberia. I've been there multiple times, and it is literally it's like walking into the beer refrigerator at Miller's, right? It's cold in that cave. And it is not like that in our cave. It's a constant temperature of 19 Celsius, which is, I think, what, 63, yeah. So it's a warm cave. Yeah?
Have you found any charcoal at all in the site?
We have found charcoal, and we cannot yet establish, we've dated some of the charcoals. Some of the charcoal that we've found is less than 5,000 years old. So we, not with these bones, but in the second chamber where we think some material has been introduced later. So we don't yet have anything that we put with Naledi.
You also mentioned that, you mentioned that there was actually, the bodies were put in there and there's still flesh and so on.
Mhm.
They probably have stomach contents, with organic materials.
We're very interested in this because now you can get environmental DNA from these cave sediments, and there is some possibility that we will find something that way. We're investigating everything we can with technology.
Did pollen survive there, or did you guys keep it oxidized?
Pollen often survives, even in these contexts. We haven't yet got a signal from pollen that we like, but we're continuing to work on that.
Especially if you're having to be eating plant materials.
Yeah, exactly. No, this is exactly the kind of thing that we're real interested in. Yeah, go ahead.
Method of death, do you see anything about disease or anything about traumatic?
So the question is, do we know anything about how they died? And the answer is no. We have absolutely no evidence of anything that we think is associated with their death. If we ask, is there any health issue or health evidence at all we have, I can tell you two things. One is there are 2 broken toe bones that healed during the individual's lives. We don't know if they're the same individual or different. We have 2 broken toes that were healed. And Zach was so excited about that. He's like, well, there's 2 broken toes. There's a paper. So there's something. And on one of the jawbones, on the inside surface of it, the tongue side of it, there is a small osteoma, a small tumor. As far as we know, totally a benign thing. There's probably 3 people in the room here who have something like this on them somewhere. It's not uncommon, but that's something we have. Yeah?
Have you studied the survey marker of the people who were there before you or dated it? And also, if you worry about robbers coming into that one that's there, now that it's known, is someone guarding the hole?
These are great questions from the Historical Society president. Yes, exactly. I can say that the survey marker, we know the origin of it and the date of it, and we think we know the person involved. We're not sharing publicly anything like that because it's somebody who today is very aged, and they didn't know what they were in or anything like that, and we don't want any attention brought to them for this. But we have tracked that. We know something about it. The protection of the site today, many of these cavers, you guys know cavers, people who spelunkers, some of them are very technical people. A lot of them are engineers. I can tell you when this site was discovered, it was on private property, but it was private property that was largely neglected. It was being rented for horse grazing, and there was a family living on it who had a connection to there was a black family living on it who had a connection to the white family who owned the property and who had once lived on it as a farm. And the blacks who were living there were in extremely bad situation. There's no services, no water, no trash to pick up or anything like that. They were living in very basic circumstances. The kids weren't in school. And the property was not maintained, right? This was a problem property in that sense. Lee has a foundation. The foundation has acquired the property. They fenced the property. They have bought a home for the family, 2 homes for the family that lived on the property. The kids are in school,
and the women who are the family heads run or now work for the foundation maintaining the site. The site is being brought back to its natural state. It's about a 50-hectare property, so about a half a square kilometer. And the site has been burned now a couple of years. We've had non-invasives being removed, or invasive species plants being removed from it. And now, after this year, there are blessbok and impala and springbok on the property, and another small antelope, steenbok, has come back on its own. And it's in a very good situation. So the site is protected. The cave itself, our clever engineer cavers have designed a series of barriers that would be extremely difficult to get into without blasting. That being said, there are people in South Africa who are very skilled at blasting underground. The gold mining is the major industry there, and illicit gold mining is a big thing. We have not had a problem with people wanting to get into the site to damage the fossils. We know we have had issues with people wanting to get into the site to say they've gotten into the site. And so that's something that we continue to monitor. We have, camera traps and all kinds of things, and security on site, and et cetera. And we're doing everything we can. It is in a World Heritage site, and so there is also the World Heritage Authority that we are responsible to, and the South Africa Heritage Resource Agency, SARA, which is the permit granting agency for South Africa for this sort of research. Yeah. So the question is about air quality in the caves. There's good ventilation in the caves. There are at least 4 entrances to the cave system, and air will flow through the cave in the direction of the wind based on pressure. And so there's good replacement of the air underground. We have done monitoring, and we monitor when we're in the cave. We have a little bit of carbon dioxide elevation when our team's underground, but not of health concern. The first time we went underground, we had an alarm go off, and we were real concerned about it, but it was set for what you'd set in your basement and not for actual danger. So yeah, we get a bit of elevation, but not too much. Not to our knowledge. The uranium content in this part of South Africa is pretty low, and the radon is mainly a side effect of the uranium decomposition, so it's not high. Yeah.
Any carbon deposits that might indicate somebody down there with a torch at some point? I can say that we have no evidence about this yet. That's something we're very interested in. One of the complications is that the dolomite of the cave, the wall has changed since in the last 250,000 years. There's deposition of calcite on the surfaces of it, and also leaching of calcite from other surfaces. So to find something that we're going to be able to place with Naledi, we've got to actually have it underneath some of those thin calcite layers, and those are really hard for us to find. We're more hopeful of charcoal being found in some of the places, but we'll see. Yeah.
I think there's good evidence that modern humans interbred with Neanderthals.
Mm-hmm.
There were other hominids around with Naledi, from what you said. Would they have interbred with each other, and did that drive the process of evolution, do you think?
So we know nothing direct about Naledi and interbreeding. And what I can say is that we do know that there was interbreeding of very different hominin populations in Africa. We see the signs of that in today's African people. And when I say interbreeding, I always mean the evidence from Neanderthals, for example, is a very low fraction. Most people who live outside of Africa now are something like 3% Neanderthal. Right? So 3%, that's like one of your great-great-great-grandparents, more or less. It's the great-great-great-grandparent is 1/32 of your genealogy, so it's about 3%. And with Neanderthals, it's about what it is. And of course, this is many, many thousands of years ago. It's not your great-great-great-grandparents lived during the Civil War, so it wasn't then, but it's that fraction of your genealogy.
there is a similar fraction of the genealogy of Africans that comes from some or possibly multiple groups of populations that were as different from each other as Neanderthals are from us today. We don't know who they were, we don't know where they lived, and we don't know really anything about them other than, oh yeah, there was somebody in Africa too. It could be Naledi. We think it's likely that Naledi did diverge from our family tree around the time that other species had its anatomy, that skull is so primitive. We think, actually, Naledi's probably been around for a couple million years. In which case, if genes came in from them, it would be very different. But that's not impossible. Animals do hybridize that have been separated for that length of time. And there's no reason for us to think it couldn't have happened. But in order to find evidence of whether it happened, we will have to have DNA from some of these fossils. And we'll see. Okay, I'll take a couple more, but you guys have been super patient, those of you. Yeah?
Have you seen this cave that's just on the west side of Vermont?
Yeah, absolutely. Yep.
How big is that?
The Cave of the Mounds, yeah?
No.
Oh, no, closer in.
No, it's only like a
Oh.
couple miles down on the west side of Vermont.
Well, somebody can tell me how big it is. I don't know.
Well, he's been in the cave.
Yeah.
Really, how big is it?
Yeah?
Yeah.
How big is the cave?
It doesn't sound like he had a Superman. Did you get Superman in there?
Yeah?
I just know.
The Richardson Cave, yeah.
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 I was never in it, but I know my parents when, well, I think maybe before I was even born, had farms, they just did a ways from there. He said there was a cave there.
That's cool,
But I
yeah.
never heard.
I was at the front of it,
Uh-huh.
I refused to go in.
That's why I've never heard of anybody being in it.
Uh-huh.
Wow.
Wow.
The Historical Society
Yeah.
has an article about people early on back in the 1840s, 50s going in there and actually getting lost. For
Oh, wow.
a year or so and then finding their way out.
So it must be fairly extensive, yeah?
Fairly extensive.
Yeah. Mm. Cool. Yeah, go ahead.
How was the project and the foundation funded?
Yeah, where does the money come from? I love answering this question, honestly. Partly because it's so cheap. I was going to say, people see all the stuff that we do and think, wow, it's so expensive. I talk to audiences like, why are you spending all that money on that? And what I love to tell people, especially around the university, right, is any one of those labs at the university. I'm at the university, I support their labs. You know, I love the fact the university is well funded and could use more money because the funding has declined and all that stuff, right? I'll say that any one of those laboratories in one of those buildings, right, the McArdle Cancer Laboratory or the UW hospitals, right, those laboratories run and their expenses are, you know, $300,000 to $1 million a year. That's our expenses for the entire project. So we're talking about a lab, you know, in real terms. Our money has been funded in part by the South African government, in part by our universities. The UW has invested in my research, and so I have some UW money from this. In part from National Geographic, who've been very generous sponsors of ours, and in part from private donors and private foundations, the principal one being the Lyda Hill Foundation, who is, she's a businesswoman in the Dallas area. So we have really generous support, a number of South African donors who've also been very generous with us. It's a South African-led project and South African-administered project, and so we're really happy to be partners with the South African National Research Foundation and the University of Witwatersrand, where I am an appointment there as well. So that's where the money comes from. Okay, yeah, one more question, yeah. Mm-hmm. Yep. So if you want to download fossils, Morphosource. Yeah, morphosource.org, and if you just Google Morphosource, you'll find it. All those fossils are available for public download. You just have to have a login, and that's easy enough. Just sign up for login. And yeah, I'm happy to have anybody who wants to come up and see some of these, see them. I hope they haven't gone away. Oh, was there a question from you in the back? Yeah? Yeah, go for it.
Is dinosaur archaeology kind of like bone archaeology?
It shares a lot, and we use many of the same methods to find fossils and to dig up the fossils and to preserve the fossils that dinosaur people do. But it's a little different in where we look for fossils, and it's a little different in the kinds of things we can find. We can work on DNA from many of our fossils, and dinosaurs, so far, it's not yet possible. But we do share an awful lot, and the geologists who work on our team trying to find out how old the sites are also work on earlier kinds of mammals and dinosaur sites to find out how old they are. Great question. All right, thank you guys.